So good afternoon, everyone. Thanks for joining us. I'm Paul Sesto. I'm Javelin's National Education Manager. If you're new to Javelin Technologies, we work with over 6,000 customers across Canada. That includes 200 academic institutions. And our additive partner, Stratasys, is the world leader in additive manufacturing. And we've represented them for almost 20 years. And Joe Yang is Javelin's technical team lead. Joe handles most of the technical support for our education clients himself. And this past winter semester, he was also teaching an additive manufacturing course at Humber College in Toronto. Joe, can you give us some of your background and your experience with our clients?
Sure. My industrial background is in mechanical design and product development, and that spans anywhere from something simple as a dog bowl, for a pet product company, to industrial size, furnace feeder or injection molding machines. I had my opportunity to work with Stratasys products starting in 2012 when I was part of the Applied Research and Innovations program at Sheridan College. And then since then, I've always been sort of like using additive for a lot of projects, more personal. And since joining a Javelin, my main priority has been, improving customer experience overall with additive manufacturing. It can be, technical support, applications, design consulting, training, sometimes, in this case for Humber, helping with, curriculum development. So in fact, myself and my colleague Corey Green, we developed a curriculum together, and then we taught that course for the third-year students for the full semester.
Okay, great, thanks. First off, I want to thank the academic additive community. I could easily name off 25 schools just here in Ontario that were involved in the 3D printing of PPE for their local medical community. I think this has been an amazing effort, and when I see some of the names online, I think there are some of the people who are online who've also been involved with this. It's been an amazing effort, and I think it clearly demonstrates just how fast ideas come to fruition and to reality with 3D printing. Okay, so let's just jump in to today's topic. I think there's a wide range of perceptions of what 3D printing is all about and what's actually possible. Stratasys was actually one of the originators of the 3D printing industry 30 years ago, and they've been heavily involved in education with the education market. And this was actually a question for Jesse, but what I'll sort of go through is that I've actually started with 3D printing about 15 years ago when I worked with Symmetric Solutions, and Symmetric Solutions actually merged with Javelin about 2 years ago. But back then, the 3D printers, and some who may have been involved with 3D printing too will remember that 3D printers were larger machines. Some people thought they were cappuccino machines, and they were perhaps limited by the I want to say limited by the amount of materials that they could do at the time, and and they were relatively sort of expensive. So it was maybe some of the school, it wasn't a thing that you saw in every school. You didn't see it in every industry, but it was certainly out there in the market. And when one of the parts, maybe Joe, I'll jump to you with this next question. When we start talking to educators and researchers about what they're looking for for a printer, or what they're doing, one of the first things that I'm always interested to learn is about what are their applications. What is it they're looking to do with the 3D printer? And maybe Joe, since you're always in on sort of early conversations, maybe you can add in or what you're looking for. And what I have to say to everyone too is one of the things that when I say Joe and Jesse are our go-to people. I think one of the things that we do well is being able to bring in for our clients the technical expertise right up front. So Joe, can you sort of give us some of your ideas on that area?
Yeah, absolutely. So, I mean, you already mentioned that, asking about the applications, but in the broader side, I would, basically get them to define the goal, right? Like what their vision is. So do they just want a printer? It's like they're not looking to buy a printer. It's more of, they want to establish a additive manufacturing lab, and for to teach the students on how to use the technology and be familiar with it, and then have that sort of that technical technological breakthrough in their conventional curriculum, right? And like besides the when I say like the main goal, it can be anywhere between a goal for a course that this printer or this printing lab supposed to support, or it can be a multi-year long-term goal. Like but if you have a vision, then that's always the best way to start, and you can describe that to us, and then we start painting the details. And one of the things that I always ask is, on the practical point of view, if this printing labs or printing equipment is supposed to support student coursework for every semester, then the most important thing will be estimating the workload and how it's going to be distributed, coming from different courses, and that will utilize the additive manufacturing throughout the semester. So this will allow us to calculate the overall throughput required for that printing lab, and also have some headroom left in it. And then we can then look into the possibility of utilizing the printers for research. Now that may require special material properties such as flame retardancy, biocompatibility, or elastic material, just to name a few.
So that sort of takes it back to the idea of what the applications are going to be. So I think the whole idea is, a lot of times people are, we do our best not to just jump to, okay, here's the specifications of printers, and at times people are asking us about the speed of the printer, the size of the bed and so forth. The size of the bed is important if you're printing large parts, but everyone can also no matter, and I think everyone's probably found is, no matter how large of a printer you have, you always want to build something larger. But it's going back to those applications. And Joe, I think there can be a lot of confusion in the 3D printer marketplace. I've seen labs with lots of small consumer type printers where they sometimes seem to salvage parts from each other to keep things going. But with these, they might need countless hours of fixing them, by the technicians or even the students. And then there are other labs that have a higher level of printer pumping out parts 24/7 unattended. How do you differentiate, from your technical side, between perhaps it's more of the marketing terms of between a consumer, a prosumer, a professional, a commercial, and a production level printer?
Right. So yeah, let's do a little breakdown. So when we say consumer or prosumer level printers, they all sort of fall into this hobby printer category, and you can buy these off Amazon or eBay, in the range of $500 to maybe $1,500. These printers are the most bare bone types that run on untested open source software, and they rely heavily on the user to spend countless hours trial and error before they can even produce a decent part after they install the printer, and then from part to part, you always have to keep going through this sort of iteration process until you get the right part every time you design your design changes. And the throughput is typically very low, and the build envelope is small for producing a batch of multiple parts at once. And then if we step up from there, there is the professional grade, what we call, and these typically do have you know, proprietary software and other tools that come with it, but it's still not as polished as commercial grade products. So at this point, the overall quality of the print improves quite a bit, relative to consumer grade printers, but they, and sometimes they offer several material options, but the throughput is still pretty low, and and there is not a lot of technical support for you to rely on. So you still have to go through quite a bit of tinkering and fixing and maintaining, day-to-day operation of the printer. And then the biggest pitfall with these printers is that the product life cycle is very short. So when you purchase a printer, in about 2 to 3 years, it will likely be discontinued, and then you can no longer get any kind of support for parts when something breaks. And then after that, you're pretty much on your own. So there's no part support, no tech support by an experienced team. And when I say experienced team, like the truth is, with these printers, when you call the tech support number, you'll likely end up talking to someone at a call center overseas for hours until you get frustrated and throw it out the window, right? And now with the commercial and production production grade, so this is where a lot of it becomes, I guess, the software package, the hardware, everything becomes sort of proprietary, including material. Sure, it definitely drives the cost a little bit up, but then it comes with all the allowable design sets, and parameters that have been tested. So you pretty much install the printer, and then you load you send the job, and then you hit go, and you are expected to have a working part right off the bat. And then the throughput is typically 50 to 100% higher than the professional printers. The more usable build envelope, because of the heated chamber and more tested parameters in terms of thermal control, and the design freedom, and the big productivity boost comes from the soluble material as well, or the soluble support material, which typically isn't available, at least out of the box, for a lot of the prosumer grade products, and even some of the professional printers. And so this brings up a point, in terms of like deciding how much time you want to allocate in post-processing, because obviously the support staff or the lab technician or lab manager, they don't have time to clean individual 3D printed parts, like all the support structure that come with it. Like you need to remove them by hand, but then if you can utilize soluble support, then you can just collect all the batch, put it in a tank, and then in few hours you have everything ready to go, right? So those are the additional decision factors. Then last but not least, the tech support, the level of knowledge that our tech support team has is just not comparable to any other call centers. And we are the ones who use these printers day in, day out, with all kinds of materials to support our own customer bases, because we also work as service bureau, and so does Stratasys. So we really know these printers, and so when you call in, when you talk about something, a situation, we know exactly what you're talking about. So there is no more misunderstanding, and you don't have to repeat yourself over and over again over the phone. Yeah, I guess that'll be the overview of for the differences between those three different categories.
Thanks, Joe. And I think the important thing to remember too, and one of the things that I'm always trying to stress to our own Javelin customers is don't, our support team, the support aspect of 3D printing is very important, because that's where you can also get information and help from the support team for applications. So a lot of time, so many times I'm telling our own customers is, don't just call into a team and Joe and we've got a team of I think it's 7 or 8 technical staff on our 3D support team. But don't just call in when you have a problem. Call in when you're trying something new, when you want to do a new application, when you want to, get into a new material. And
Absolutely.
I think that's the important aspect. And I think for us with our Stratasys printers, it's our Stratasys printers are all falling in that commercial and production level, because what we supply to schools with our full line of Stratasys products is the same line of printers that we're putting into industry. And the other aspect too is what you're perhaps looking to do in schools, may have been done in industry, and it's where we've got the advantage of being able to bring that information from both sides there to help our customers. Joe, people seem to have a sense of value when it comes to laptops, computers, shop equipment like CNC mills and lathes. But why do you think people start out with this impression that all printers are the same? That they'll all do the same thing? I guess, sorry, I'll back up. They do all print, but it's why do they think that you can talk about all printers doing, being of the same value, I guess?
Mm-hmm. Yeah, so I think the biggest issue is that the 3D printing community, by and large, in the public domain is mainly driven by the hobbyist groups. And this is the DIY demographic that enjoy spending time tinkering and fixing things, and they're usually satisfied with a product if it can produce a usable part or two once in a while for their projects in their garage, which has very little pressure on timeline. So this allows these consumer/prosumer market products to receive rave reviews. Oh, you produce a part, it's great, right? But in academic situation, or even in industrial commercial applications, like you simply can't afford to keep trying and trying different things until you get one part right. Like when you have project timelines, and especially for schools, the faculty has to have all the students finish their projects so they can mark them and then upload, and so it goes on their official transcript, right? So the second reason would be the misleading advertisement by some manufacturers, not all, some, that they often hide the flaws and tend to highlight the unrealistic mechanical performance figures. Those usually aren't relevant to the actual quality or the throughput, but they'll just say, this printer can move the head by 200 millimeters per second, which really doesn't mean anything, because those printers clearly don't have that, the ways to manage the thermal stress for the printer to be able to actually print something without warping or causing all kinds of issues afterwards. And I visited several universities and colleges that went through the same path. They first start with a hobby printer, a whole bunch of hobby printers. Mm-hmm. They get frustrated. Half of them will work, and the other half is really just as a backup, so they can fix it. So you always have this 50 down, 50 up type situation. I've seen it at many colleges in their labs, and then eventually they end up investing in the right manufacturing equipment, not a toy, right? We often think because it says printer, it's called a 3D printer, so we think of buying a printer, but it's not. It is a manufacturing equipment.
Okay, terrific. It's been a bit of a mantra of mine that on the education side, that and I'll state this here and sort of answer it for myself. This was a question for Jesse, but that Javelin strongly feels that in order for schools to be successful with 3D printing, they need two components: safe, reliable, and robust 3D printers, such as our Stratasys printers, and we've gone through that. And the other aspect is a learning curriculum integrated into their STEM or STEAM program. And it's one of the things that it's typically, say, when I'm dealing with elementary and high schools, and everyone's jumping on, everyone wants to jump on the bandwagon of 3D printing, and the aspect that they, don't think about first, and which I try to bring to the forefront is, how are you going to use the printers, or how are you going to integrate it into your program? And this is where, through Stratasys, we do have curriculums, lesson plans, ideas. There's a lot of things online for instructors and teachers to use. And I think it's important that, and this is why I stress, always these two components. The printer is only part of it. What it comes down to, what are the students going to learn? How are they going to take advantage of this? And what I always come down to, it's about the design process and about problem solving. That's really, from the education side of what 3D printing is about. And Joe, maybe that leads into the next question. And I know we're running a little bit over time, but if people want to join, stay with us, we'll be through on our questions about 5 minutes. And if you have any questions for Joe, type them in there in the chat, and we can run through that. We're here for as long as what people need or can stay. But Joe, from your teaching experience at Humber and from your experience in the field, do you see any difference between setting up a lab that's maybe servicing 400 engineering students in a semester design course to what's the difference with a general print lab for a whole department or faculty? How do you sort of see those perhaps as different setups?
So it really comes down to applications, of course. For a general printing lab for the faculty usually involves a lot, printing, research projects, right? And those will likely need, some kind of special materials, with certain characteristics that the researcher wants. But then when it comes to, setting up a printing lab just to support, mainly to support, like a design course for students, a few hundred students especially, then the key is to keeping things simple. Just when you hand out these design project requirements for the students, what I did at Humber was to restrict everyone to use just one type of material. Exploring other material is one aspect of additive manufacturing, but the design ingenuity doesn't change. The principle of good design doesn't change whether you're using a basic material like ABS versus a really exotic aerospace grade like Ultem 985 or 1010. So the reason is it takes a long time to switch over material in a printer. And the faculty clearly doesn't have the time to do that, stick around hours, while the printer stabilizes in temperature and calibrate the tips and all that stuff. So keep it simple, one material, and get something that is simple to operate and just keep popping out parts. And you typically something like 2 or 3 F-series in a lab is adequate for something like this. And on the other hand, for a research lab or research focused lab, we'll have like a Fortus 450 to enable all kinds of exotic material. And on the side, it'll have maybe 120 or 170 to complement for printing something simple like a bracket for sensors and whatnot.
Okay, thanks, Joe. You're a little bit broken up there at the end, but I think we got the point.
Oh.
And no, and we got the point because I think the thing is that what you're saying is with the student lab, it's all about output and keeping it simple. With a general lab or a research lab, it's about having variability and having options, to have having the material options for the applications that they have. Joe, we sometimes see that people are leaving the logistics of where the printer equipment is going to be located. It's sort of an afterthought. What's your advice to make all this run smoother, or what's your advice on sort of best operation conditions and efficiency in setting up printers in a lab?
Well, the most important thing is space. Like you need to have the space around the printer. I often see at schools, just like you said, placing a printer becomes sort of an afterthought, so they end up pushing it into a corner in the lab. But like any manufacturing equipment, like it needs to be maintained periodically. And if you don't have the room to work on the printer, it really degrades the overall user experience, and that leads to poor housekeeping. Like housekeeping and storing material are the two most important thing for reliable printing operations. So yeah, that will be my suggestion. Keep it, give it ample amount of space. Obviously, you want to have it in a dry place for the material, and then after that, it's all about housekeeping.
And I understand from that, because I know that we do have some of our education people come into our labs. They see our setup. We've got a full-on additive lab. I think it's 3,000 square feet.
Yeah, 3,500. Yeah,
3,500.
Yeah.
And they see our equipment that we have, with even sometimes tool chests, different equipment, that we have just to use on the printers, and we share that information. They ask us, hey, where did you get this piece of equipment or that? And it's not the printers, it's the other additional tools. I think so. There's some tools from Lee Valley and different storage bins and that, and we're more than happy to share that kind of information. So one of the things that I deal with, from the education grant side, is that for most of colleges and universities that we work with, they have to apply for grants, and these can be anywhere from 6, 12, and even 18 months out before they find out whether they have the funds. And sometimes they're concerned about that by the time they get approval, that the Stratasys printer may, have changed, with new features or technologies. But I always want to, I talk to people about this, and even when, when they finally get the grant, what we're able to do, and sort of rest assured to everyone, is that what we'll always do is sort of revisit, your applications, what you're still trying to do, and we'll make sure that, the solution that we first proposed still fits. And if there are new features within the technology, such as on our Stratasys Fortis 370, and just generally in that the Stratasys 123 line, they're continually adding to the material options. So you might have applied for a grant and it had 4 materials, and now it has 6. So there's always, in general, we're always able to add more, as time goes on there. We're going to wrap up, and if anyone has questions, you can type them in the space now. And I'm just going to have Joe, Joe, if you can just summarize, what's your, top couple of 2 or 3 pieces of advice that you would share with everyone?
The first would be, to remember that 3D printers are, or 3D printing is a form of manufacturing technology. So it should be treated as such. So you're not looking to buy a toy, you're buying an actual equipment. And second, look far into the future, look for a long-term goal of the lab. Like what do you see, what your students will be doing with 3D printing in the next 5, 6, 7, 10 years, right? And then the last one will be, don't hesitate to ask questions. The better you're informed, the better decisions you'll make, and we're here to help. So whether it's applications or actually setting up the lab, even if if you want to know about the where we got these fancy tool drawers, let us know. We will be able to help you. And yeah, that's it.
Okay, thanks very much, Joe. And as I said before, that's the whole thing, is that we're here to help. It's more than just the printer. It's the support that we're able to offer, and that support is upfront when you're planning for your research lab, when you're planning for for your student labs. And that's where, and this is why, you know, as I said, we pull in, I pull in Joe and the rest of the team, whoever's needed, in order to help best advise everyone. So I don't see, I don't see any other, any questions there. I know we're a few minutes over time, but I'd like to thank everyone for joining us. And oh, we do have a Joe. I don't know whether we might be able to answer this. We do have a question here. Any chance of Stratasys is coming up with a build plate tape or glass bed to replace the costly and I will say wasteful build plate? I'll read this off. The build plate that we're using with the Uprint SE Plus.
Unfortunately, I don't have an answer to that. I don't know what Stratasys will do, but as of now, you know, since the F series is still using those plastic beds, I really don't see it changing anytime soon. But you know, there are, you know, several strategies where you can, you know, still reuse some of the you know, build plates that you're referring to. So we can offer some tips and tricks if you you know, reach us separately.
Okay, I know I see who it's online, and maybe others do. So maybe we'll Joe, maybe I'll get you connected up with Jerry. I know he's a long time Uprint user.
Got it.
Okay, well, thanks very much to everyone, and for joining us here. And the other aspect, you know, if you're new to Javelin, or even those who know us from Javelin and Stratasys, we also, on our additive team, we're also now doing metal 3D printing, and we also do 3D scanning. So, you know, if you have questions or areas, you know, that you're getting into that for your lab, by all means, give us a shout. And I'd like to just, again, thank everyone for joining us. And, you know, we're here and available to help you. Thanks, and everyone have a great afternoon. Cheers.
Thank you, everyone.
Thanks, Joe.